Pythagorean Theorem is named after Pythagoras, a Greek philosopher and mathematician who was the first to write a proof of the theorem based on the size of a right triangle. Pythagorean Theorem states that if a triangle is a right triangle, then the sum of the squares of measures of the legs is equal to the square of the measure of the hypotenuse. So, if C is the measures of the hypotenuse, and A and B are measures of the legs, then A square plus B square is equal to C square. The Pythagorean triple is a set of three non-zero whole numbers, A, B, and C, that satisfy the equation A square plus B square is equal to C square. Converse of the Pythagorean theorem: if the square of the longest side of a triangle is equal to the sum of the square of the lengths of the other two sides, then the triangle is a right triangle. If the square of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is an acute triangle. If the square of the longest side of a triangle is greater than the sum of the square of the two other sides, then the triangle is an obtuse triangle. A right triangle is a triangle with one interior angle equals to 90 degrees. In a right triangle, the short legs meet an angle of 90 degrees. The hypotenuse of a triangle is side opposite of 90-degree angle. Okay, let's have an example for the Pythagorean theorem. So let us consider triangle ABC with angle B is a right angle, or angle ABC is a right angle, and line segment BD is perpendicular to line segment AC. And when we say perpendicular, form a right angle, so that angle BDC and angle BDA are right angle. Oh, by the way, class, how many right triangles form in the figure given? Yes, very good. We have 3. Right triangle ABC, which is the given, right triangle BDC, and right triangle BDA. Okay, so the similar triangle from the figure, we have right triangle ADB and right triangle ABC. Since they are similar triangles, so the corresponding sides are proportional. So that AD is to AB equals AB is to AC. Or otherwise, AD times AC equals AB opening close parenthesis square using cross multiplication. And let us consider this is the first equation. Okay, another similar triangle from the figure, we have right triangle BDC and right triangle ABC. And since they are similar, so the corresponding sides are proportional. So that DC is to BC equals BC is to AC. Or DC times AC equals opening close parenthesis BC square using cross multiplication. And let us consider this is the second equation. Combine the first equation and the second equation, so that AD times AC plus DC times AC equals opening close parenthesis AB square plus opening close parenthesis BC square. So that AC times AD plus DC equals opening close parenthesis AB square plus opening close parenthesis BC square. Okay, AC, the common factor of AD times AC and DC times AC. So that AD times AC divide by AC, so that the answer is AD. DC times AC divide by AC, so we have DC. And from the figure, AD plus DC equals AC. So that AC times AC, so quantity AC quantity square equals opening close parenthesis AB square plus opening close parenthesis BC square. Therefore, if we let AC equals C, AB equals A, and BC equals B, then A square plus B square is equal to C square. Okay, let's have an example. Let us identify what kind of triangle given the size of the triangle. If A is 5 meters, B is 7 meters, and C is 9 meters. So, according to the Pythagorean Theorem, A square plus B square equals C square. So, when we substitute the value of A, B, and C, so that A is 5, so that 5 square plus 7 square equals, so 5 square is 25, and 7 square is 49. So, the 25 plus 49 equals 74. So, C square equals 9 square. So, 9 square equals 81. So, that 81 is greater than 74. So, what do you think? What kind of triangles is that? Okay. So, C square, which is the square of the longest side. And if that is greater than to the sum of the square of the other two sides, so that your triangle is an obtuse triangle. Now, how about if the sides of the triangle are 8 millimeters, 15 millimeters, and 17 millimeters? So, for that, let us substitute now. So, again, A square plus B square. So, your A is 8, so that we have 8 squared. And B is 15, so that we have 15 square. So, 8 square is 64, and 15 square is 225. So that 64 plus 225 is 289. And C square equals, so C is 17, so that 17 square equals 289. Okay, what have you noticed, class? Yes, correct. They are equal. So that when we square the longest side, and if that is equal to the sum of the square of the other two sides, then the triangle is right triangle. Let's have another example. So, given a right triangle, so the other two sides, we have 6 and 8, and the longest side is missing. So, since the longest side is missing, so that our formula will be C square equals A square plus B square. So, what we have to do is we are going to substitute. So, your A is 6, B is 8. So, that C square equals 6 squared plus 8 squared. So, C squared equals, so 36 plus 64. Then, extracting square root both sides. So, C equals square root of 36 plus 64. Then, C equals square root of 36 plus 64, we have 100. And C equals square root of 100 is 10. Therefore, if the length of the other two sides are 6 and 8, so the length of the longest side will be 10. Okay, example number 2. Given a right triangle, B is 4, C is 5, which is the longest side, and A is missing. So when we solve for the value of A, our formula for that is A square equals C square minus B square. So what we have to do is we are going to substitute the value of C and B. So that A square equals 5 square minus 4 square. So A square equals 5 square is 25, 4 square is 16. So that 25 minus 16. Then extracting square root both sides so that we have A equals square root of 25 minus 16. And 25 minus 16 is 9. Therefore, A is equal to square root of 9. And what is the square root of 9? Yes, correct. A equals 3. So that, if the longest side is 5, and one of the other side is 4, so that the length of the other sides of the right triangle is 3. Thank you.